Alright guys, this is 5.5. We're going to hit on radioactive decay, but before we do, let's look at the warm-up. And the warm-up comes from 5.4. Alrighty. Now if you notice, I have logs of both sides on this side, but there's not one there. Okay? But since I have log and I have the same base, I need to rewrite that as one log. So I'm going to write log base 7 of 5x, what corresponds with a minus, divide by 3. And if you want to put parentheses around it, you can, equals 1. See how you have log on one side? Keep these together, equals that one. You can write it, change it to your exponents, okay? So what's your base? 7 to the y, 1 equals 5x divided by 3. And now you can solve for x, because it says to solve. 7 to the first power is 7, is equal to 5x divided by 3. How do you solve? Get rid of the fraction. Opposite of dividing is multiplying. What you do on one side, you do to the other. 3 times 7 is 21, equals 5x. Solve for x. Divide 5 on both sides. So x is equal to 21 over 5. Okay? Check your answers. 21 over 5. So here we go. Let me clear that. So alpha window number 5, base 7 of 5 times 21 divided by 5. Oops, let me delete that, get out of it. Minus alpha window number 5, base 7 of 3. Did it equal to 1? Yep. So guess what? This is the correct answer. Always check your work when you are solving. Okay? Alright, so now we're going to talk about radioactive decay using carbon dating. So students will be able to determine the rate of decay based on exponential growth. Oh, my fault. Students will be able to determine the rate of decay based on exponential growth. By the way, that's a Greek letter for alpha. All right, look at all the atoms. Okay. We finally know enough to address radioactive decay. Suppose a saber-toothed tiger fossil is located on I can't talk. Archaeological. I can't talk. I know that word. Okay, archaeological site, dig. That is weird. I can't say that word. Archaeological. There it goes. After analysis, it appears that there is about 15% of the original carbon-14. Carbon-14 has a half-life of 5,730 years. That should say years, not tears. Okay? Using carbon dating, determine the age of the fossil. Now, what formula am I going to use? Well, the formula you're going to use is the one that's continuous. Why am I using that one? Okay? Because if you do that one, people don't just, like somebody dies. It doesn't just decay and goes, oh, I think I'm going to stop for a few years. Okay, I'm going to decay some more. Oh, I think I'm going to stop for a few years. No, when you are getting eaten by those bacteria, you are continuously going to be decaying. And that is the reason you use that formula. Okay? All right. So here's a website if you want to go to it, and this is what we're going to do. So let's learn some keywords before we figure out how to do them. Radioactive decay. Radioactive decay, here I can make this a little closer. Okay, there we go. Radioactive decay is the process by which an unstable atomic nucleus loses energy by radiation. Hence the word radioactive. Carbon dating, the determination of the age or date of organic matter. Organic contains carbon. Matter from the relative proportions of the carbon isotopes, carbon-12 and carbon-14, that it contains. Half-life, the time taken for the radioactivity of a specified isotope to fall to half its original value. For example, if you take a medicine and it's good for 8 hours, about 4 hours is the half-life, and then the medicine starts to decay. It's not going to be as potent as it would have been when you first take it, the first half. That's a half-life. All right, so now let's go back to the problem, okay? And there's the question, if you want to know what to do it, and it just says, we finally have enough address radioactive. Okay, what do we know that we can plug into the formula? Well, let's see, all right? The question says, you know that it appears that there is about 15% of the carbon-14, so your rate is 15%. Okay, well, hang on just a moment. All right, what do we know that we can plug into the formula? Half-life is 5,730 years, carbon 14. Okay, so let's take a look. We're talking about a saber tooth. Okay, so what do we know? A percent, remember, anytime you see the word percent, is out of 100. Okay, so it says, I wish I'd made that bigger. It appears that there is about 15% of the carbon-14 left. Using carbon dating, determine the age of the fossil. This is going to be a two-step process. Step number 1, all right? We know it is at 15%. And we know the half-life is 15 out of 100. Do you guys see that? We don't know the rate or the time. So this we don't know, and this we don't know. So we have 15 out of 100 continuously. So this is how you would first start it. 15 equals 100 continuously. We don't know how fast that carbon is declining, and we don't know how long it took. We just know half-life is 5,730. All right. So step number 1, find how long it takes for carbon to be at half-life. Depending on what the organism is, or what it is, that will change. So now you can use algebra to solve for the R. Remember logs. Okay, so step number 1, find how long it takes the carbon to be at half-life. What is half of 100? 50. Do you guys see that right there? So 50 out of 100, so this is step 1. This is step number 1. Find out the rate. Continuous R at half-life is 5,730. Okay? So now we are going to solve. You can do it many ways. All right. You can type this into the calculator, but you guys already know how to solve now. So let's go ahead and solve. Okay. So we're going to solve for R. You guys ready? Divide each side by 100. Okay, so 50 divided by 100 is 0.5 equals base, and I'm going to rewrite this where the R comes in next. All right. Notice the R is an exponential position, so I need to rewrite this as a logarithm. Okay, so log base E, here's your base, here's your y, this is your x. Remember that? I'm going to rewrite it. Log base E of 0.5 equals 5730R. Okay? Another word for base E is natural log. You guys see it right there? So instead of writing log base E, I'm going to write natural log, because to do base E, you have to go alpha window number 5, second E. You see how that took a lot of time? Instead, you can just go natural log, just the LN, okay? Divide both sides by 5730. Cancel, so R is equal to, all right, so natural log, 0.5 in parentheses divided by 5730. So what is the rate? Now, you guys see that E? That's just an exponent, okay? 4 decimal places. So negative 1.2097 times 10 to the negative 4. That is the rate of the decay at half-life for carbon-14. Okay, that is not the question. The question is, how long? We want to know the age. The rate is not the end goal here. So your next step, so step number 1, find out how long it takes for the carbon to be in half-life. Find R. So we found R. Step number 2 is a 2-step process. Use the rate of half-life to determine the age of the fossil. Solve for T. All right. Okay, here we go. Now I'm going to rewrite this to make it look like my answer earlier. Negative 1.2097 times 10 to the negative 4. Same thing. I'm going to rewrite it, okay, so I can show you how to use it. how to type it in, and that would be better for you. Okay? Alright, so here we go. Same thing. Divide each side by 100. So 0.15 equals e raised to the negative 1.097 times 10 to the negative 4. And if you want to keep it together with a parentheses, there you can. Okay? Here's your base. Here's the x. Here's your y. Rewrite it as a logarithm. So log base e of 0.15 equals negative 1.097 times 10 to the negative 4. Or you can type in that whole number, t. Okay. How do you solve for t? You divide by 1.2097 times 10 to the negative 4. And what you do to one side, you do to the other side. That cancel, and there you have t. Alright, now let me show you guys how to type this in using exponentials. Okay, scientific notation. Okay, can you guys see that okay? Alright, so instead of log base e, I'm going to replace that with natural log. So natural log 0.15 in parentheses divided by, okay, watch how I type this in. You do not need a parentheses. Negative 1.2097. You see this EE right here. You guys see this EE right above that, under the sign, okay? It's blue, so second E. See that E shows up? That's a times 10. Negative 4. So, how long did it take? T is 15682.57 years. That's how old that is, that saber tooth. Okay? So step number 1, find the rate. Step number 2, use that rate to help you find the time. So make sure you know how to type this in. It is the EE button for the times 10. Okay? But it'll show up one E on your paper. Alright, let's do another one. Let's try another. Even though the decay, oops, I'm so sorry. Even though the decay carbon-14 is the same every time you do it, we're going to practice finding it again to see the reasoning behind the process, as well as practice solving complex exponential problems. Because you don't always use carbon-14, especially if it's an inorganic material. Alright, suppose a document is found in your backyard and you want to know how old it is. You get it tested and the results tell you it has 85%, so it has 85% of the carbon-14 remaining. How old is it? Okay. Now remember, half-life is 5,713 for carbon-14. Okay? Alright, step number 1. Find the rate. So, half-life, 50 is equal to 100. E raised to the R times 5730. And why did I use this number? Because that's a half-life. Okay? Divide both sides by 100. 0.5 is equal to E raised to the 5730 R. Okay? So far so good. Rewrite it as log base E. Some of you could go ahead and write natural log. That's up to you. Equals 5730 R. Notice there's a pattern to this. So natural log divided by 5730 is equal to R. And what did we find for R? Alrighty. Natural log 0.5 in parentheses divided by 5730. Okay. Negative 1.2097 times 10 to the negative 4. Okay. So there's your rate. I will be looking for the rate. Step number 2. Find the time now that you know what the rate is. They say there's 85% left. At the rate of negative 1.2097 times 10 to the negative 4. And if you want to put parentheses to help you, please do so. And I want to know what the t is. Okay? Divide both sides by 100. 0.85 equals E. Negative 1.2097 times 10 to the negative 4 t. Rewrite natural log base E of 0.85 equals negative 1.2097 times 10 to the negative 4t. Divide both sides by that number. Okay, and you're going to get t. All right, what you do to one side, you do to the other. Here we go. Natural log 0.85 in parentheses divided by negative 1.2097 second EE, second comma, negative 4. Just like that. Okay, so how old is this document? 1,343.46 years old. That's how old that document is. So remember, find your R and then find your T. Okay? Two-step process. You guys find out the rate first before you can use it to help you find the time. All right. So here are some ways that you can use carbon dating. Here are some formulas that goes with this one, the continuous. Sometimes you may see it like this. P of 0, here's P of 1, that's just the beginning. Instead of P, sometimes you use N. Notice how this one, this right here is your B. Okay, so there's just different ways you can see it. Alrighty, so here's your assignment for 5-5, and that will be the end of the unit. Take care. Remember, it's a two-step process. Don't go too fast. Thanks.